All right, so let's start with this one. I would say the only thing on here, DF, you could have written in coordinate point form. That's how it will be if it's multiple choice. So it would have said 0, comma A for that one. Any questions on that one, Andrew?
If you write it I is less than X, is that still the same thing? Is that fine?
For 5A?
Yeah, for 5A.
As long as the sign's going in the right direction, yes. But if it's multiple choice, the X will always be written first like that. Yep.
You couldn't put J, right?
No, I is where it changes direction.
Does J not work?
J does not. So it's where, nope. This is where it changes direction right there. As far as like quiz goes, I tried to make it pretty obvious. Like sometimes it's a little bit shaky right there, but I tried to make it pretty obvious. If you keep going, so like if I look, you have to look at it pretty closely, but if you look, come on, yes, you can go if that's what you're asking. You're welcome. If you keep going from here, like if I keep going from I to J, this little segment here is no longer on the downward sweep. That would start, like if you think about like, would it collect water and pull it in? It does. So usually I would say I try not to make it that close. It's like on the AP test or anything like that, it was pretty obvious. So, but that's how you know. If you continue on that path, does it turn into the upward sweep? And it does. So you'd have to stop it. Yeah.
How do we know when to put it in interval
If it was an open-ended question, I would have taken either, but on a multiple choice, which is what I said yesterday on the multiple choice, which is your quiz I made multiple choice, it will be in inequality.
And because I was confused because I put it in interval notation because it said on what intervals.
Yeah, but that could be inequality or interval. Yep. All right, then this question, and I left on the answer for I, but hopefully you caught it. For the single I, it is C, it is negative and increasing, sorry. And then for the double I question, it should have been the rate of change was decreasing because the graph is concave down. Remember, you need both parts, that it's decreasing, and why it's decreasing is that it's concave down. You would need both parts. Okay, example 5 on the next page should have been C. Example 6 should have been D. 7 should have been C, and 8 should have been B. Questions on those? Yeah.
7 is actually concave up or down.
So it's the rate of change increasing or decreasing. If we're talking about rate of change increasing or decreasing, we're saying concave up and concave down.
Okay.
Whereas if it just said the interval is increasing or decreasing or positive or negative, now you're not talking about concave up or concave down. So you got to know that it's rate of change. Rate of change increasing is concave up. Rate of change decreasing is concave down. Andrew.
For 6, why is it not B?
So it says, which of the following is true about the rate of change? So which one? Why isn't it not B, you said?
6.
Yeah, but you said B?
Yeah.
The rate of change is negative on the interval B to C. So B to C, rate of change, positive or negative, is based almost like slope. If it's going up, it's got a positive rate of change. If it's going down, it has a negative rate of change. So from B to C, you're definitely going up, which would mean it has a positive rate of change. It's decreasing, but it has a positive rate of change. So those are two different things.
So when it's saying like positive or negative, not referring to the rate of change.
So, positive or negative positive, negative, just the graph itself, you're looking for above and below the x-axis, right? If it's positive, it's above. If it's negative, it's below. If you're talking about positive, negative rate of change, you're talking about, is my rate of change the actual value, which we're going to get to more today, positive or negative, which means it's like slope. If it's going up, it's positive. If it's going down, it's negative. And then if you're talking about increasing, decreasing, if it's just regular increasing and decreasing, you're looking for where it goes up. This would be increasing. This would be increasing, okay? And down, decreasing, decreasing. But if you're talking about rate of change, increasing, decreasing, now this is concave up and concave down. So if I use that same graph, my concave up would be, let me do a different color, would be the U at the bottom. And the concave down would be this part. So it's definitely confusing, and the language is there to kind of throw you off. You've got to know what they mean separate. So if we're just talking about a positive and negative on the graph, you're looking above or below the x-axis. If you're talking about a positive or negative rate of change, you're talking about slope. If you're talking about an increasing, decreasing graph, you're looking for, is it going up or is it going down as you move left to right? And if you're talking about increasing or decreasing rate of change, now we're talking concave up and concave down, the U or the N. Does that make sense? You've got to be able to distinguish the language, okay? All right, now let's talk about our AP classroom questions. So number one just said, which of these would be concave down? We were looking for where this, in my actual box, said rate of change. So it's not talking about the graph, it's talking about the rate of change. We're looking for the rate of change is decreasing, which would be C, when Kumar comes back. For the toy car, you're trying to figure out what graph that looks like. If you think about it, starts here, it moves away from the point, it comes back towards the point, and then it would repeat, moves away from the point, back towards the point. So the distance is increasing, it's going away, and then it comes back towards it. It never goes past it. So when you look at your different choices, A was the best one. You would start as though this was the wall. You're going away from the wall. Then you're coming back towards the wall. Then you're going away from the wall. You're coming back towards the wall. So those, if you did this one, it's like you're going past the wall. So that doesn't work. This, the distance would always be increasing. You're always going away. This took sharp edges, meaning it would go there and back, not a circular motion where it's slowly going there and slowly going back. So these two are pretty similar, okay? But A is the better answer because it's a gradual distance away and a gradual distance back. Not a there, turn around, sharp, go back. All right, 3 from from 2 to 6. If you look at the part of that graph, it made that N shape, which means it's concave down, which means the rate of change is decreasing. Number 4 was like the word problem that we did on the notes. It said the height of the ball. It gave you a function. You had to graph it on a graphing utility. If you did, it went up. It came back down again. And then it said, which of the following describes the height of the ball above the ground? Well, the height above the ground was that the height above the ground was 15.24. Wait, no. The height of the ball gets to the maximum height. So its maximum height being 15.4 was not right. 15.240 is where it starts, but then it gets higher. So the peak of it was 16.228, which was the same for C and D. But then it says the height of the ball decreases until it reaches the ground 2.269 seconds after it reaches its maximum height. You had to find out what the X value was when it hit the height, and then you had to find out what the X value was when it hit the ground. And the difference between those two was 1.82 seconds. So that's why C is the better option than D.
So wait, which X are we looking at?
You needed both because it said it says the height of the ball decreases until it reaches the ground 1.82 seconds after reaching its maximum height. So we needed to know the difference in these X's. The X of your 0 minus the X of your max was what you were looking for. All right, 5 said, which of the following is true about 3 to 4? 3 to the 4, the rate of change was decreasing, so that rules out B and D because I need it to be concave down. And then it's positive. If my rate of change is positive, that means it has an upward slope. If it has an upward slope, then that part of the graph is increasing, which is why A was the better choice. And then 6, the water's poured into the vase. It starts clearly concave up, which means your rate of change is increasing. But it says, the second part says, the next portion of the graph is a fairly steady and steep increase. So if it's steeper than the first one, that means it's being poured faster. And when you look at your options, you wanted it to be faster in the beginning, and then you wanted it to be even steeper after that. And that's why B was a better option. Questions? Okay, we're gonna start rate of change today. We'll see how far we can get, okay? So rate of change takes what we learned like yesterday and it gets it to be a little bit more specific. Rate of change is very similar to slope. You're talking about the rate of change of a graph, okay? So in general, average rate of change is the ratio of the change in the output values to the change in the input values over a specified interval. If it is a line, then the rate of change is literally the slope. Let me just... the average rate of change describes how two quantities would have changed together if the output consistently changed by the same amount over a specified interval of the domain. So basically, you are finding the change in y over the change in x. The way we word it is this little guy, this is a delta symbol, this is what that's called, okay? That little triangle represents change. So the shortest way to do it is change in f of x over change in x. Again, f of x just like y. And then if you are actually separating it out, it's the f of x2 minus the f of x1 over x2 minus x1. It's the same thing as y2 minus y1 over x2 minus x1. It's just in function notation. So we're going to learn how to do this a lot of different ways. If I gave you actual points, if I gave you a chart, if I gave you a graph, if I gave you a function and you had to find it, like all the different ways we're going to find average rate of change. This is one of those skills that gets carried through almost every single unit as we move forward. All right, positive versus negative rates of change. And we kind of just talked about this on those questions. A positive rate of change indicates that as one quantity increases or decreases, the other quantity does the same. So a positive rate of change, my x values, if my x values increase, my y values increase. So it has that upward motion. It doesn't have to be linear, okay? But it has that upward motion. Now the same thing happens in reverse. If my x is decreasing and my y is decreasing, then it also would have a positive rate of change. If you think about rise and run, you can, if something has positive slope, I can move to up and to the right, or I can move down and to the left, and they would both have positive slope. The same idea for rate of change. A negative rate of change indicates that as one quantity increases, the other quantity does, what does the decreases? What does that even mean? The other quantity decreases, sorry. So as one increases, x increases, then the y would decrease. That would be negative. And the reverse, if the x decreases, the y would increase. That would still be negative. So positive x, negative y, negative x, positive y. On the first one, they are both positive or both negative. If you're physically looking at your graph, then you're looking for an upward motion, okay? If it's going in an upward motion, whether it's above or below the axis, that would have a positive rate of change. If it's got a downward motion, then it would have a negative rate of change. All right, example 1 says, use the information from the table to find the average rate of change on the given interval. So this will specifically give you the interval itself. Oh man, I thought I fixed this. This also needs to be changed. All right, A, from 3 to 13. So remember, these are your x values and these are your y values. If I'm doing from 3 to 13, I'm going to isolate just those two. And I'm going to say the S of 13, the long way to write this out would be S of 13 minus S of 3 over 13 minus 3. The short way is grab the y's and grab the x's. So the y where it's 13 is 10. The y where it's 3 is 4, or the output and the input, the output of each. And then the x of each would be 13 minus 3. So I'd get 6 over 10, 3/5, which is a totally acceptable way to leave that answer. Because this is a decimal that terminates, you can also make this 0.6, and that is also a perfectly good way to answer that question. Obviously, if it is multiple choice, it will be one way or the other. Okay, this should say from 1 to 4. So what's the y, or what's the output when it's 4? -7. So I do -7 minus the -2 over 4 minus 1. I'd get -5/3. And this time I'm going to leave it like that, okay? If you put it into decimal form, that would have to be rounded because it's a 2/3. So it's better to keep it exact. If it is in decimal form, then you would see it as 0.667 because it would be rounded to 3 decimal places. Well, it would be 1.667. Mm-hmm.
What number is that
On A.
That's an S, right?
Yeah, because that's the function notation. So it would be like s of 13 minus s of 3. It would be the same thing as f of x. Doesn't matter, except that this one used specifically s. Now, because it gave me units, it could also ask for the units here. So that is feet per minute. Feet per minute would be your unit, okay? So if it says include your units, or if it's a real world word problem, it tends to ask for units. You would want to make sure you include it. It would be for both. Questions on that one? All right, example 2, we're going to use our calculators. This says find the average rate of change of the function on the given interval. And it says f of x equals ln 7x on the interval from 3 to 10. So first way is literally just plug it into your calculator. ln is next to number 4. It's underneath the log button. So if I did ln of 7 times 10, I get 4.284. Okay, we're going to keep the decimal place 3. 4.248 would be the answer there. If I did ln 7 times 3, I get 3.0045. So, only 1 0, sorry. 4.0445, which is going to round to 3.045. Right next to 4, the number 4, left. So then I'm going to do this guy minus this guy over 10 minus 3. So I would do 4.248 minus 3.045 over 7. 4.248 minus 3.045 divided by 7. And I get 0.1718, which is 172. Okay, that's one way to do it. Okay, the other way to do it, this would be like second. So the way we just did it is probably the least accurate, okay? A little bit more accurate is instead of rounding to the 4.248, okay, I'm going to go back and grab those answers. So if you arrow up to 4.248 like that, I can hit enter. Minus, I can arrow up to the 3.044, enter. And then I can, excuse me, hit enter on that. So that keeps the whole decimal there at the end, which means it's going to be more accurate. Then I could divide that by 7. And it's still going to round to the same answer, okay? But that is a more accurate answer. The most accurate way to do this is go to your y equals and type in your equation. So I'm going to do ln 7x, 7x, and hit enter. I promise you, you're going to want to learn how to do this. So make sure you're paying attention. Okay. Now I'm going to go back to my home screen. Okay. And there's a way to recall that equation. So the way I recall it is alpha trace. If I do alpha trace, I get this little box that, hold please, there we go. A little box that pops up that says y1, y2, whatever. So if I had to add multiple equations in there, then I want to just pick the one that I have. I only type something into y1. So I hit enter on that. And then I open the parentheses and I hit 10 because that's the first one. Because I go the 10 minus the 3. Oh, it's so slow and laggy. I'm going to do it again, and then we'll try to I'll just walk it through again. I know, but I can't do anything about it. Minus alpha, I'm recording it, so it's there. Alpha, trace, and I go to the y equals 1 again. Open my parentheses, and I plug in 3, because that's the next one. And then I can hit enter, and then I can divide that by 7. I'm going to show you one more way to do it, okay? And that is put that whole thing in one fraction. So if I go alpha y equals, I'm going to create a fraction. Remember, some of you have the shortcut button, but I have to use that one. And then I'm going to do alpha trace y1, open parentheses, 10, close the parentheses, minus alpha trace y1, open my parentheses, 3, close the parentheses, and in the bottom, this time it was easy to do 10 to 3, but let's say there was a decimal in my x values. I can simply type 10 minus 3, whatever my x values were. I can actually type them into the bottom. So it looks exactly like that. And then I hit enter. Remember I said you're going to do rate of change literally until the last unit. You're going to do rate of change literally until the last unit, okay? That is the easiest and most efficient way to do it. You take your function, you put it on your y equals, okay? And then you do your y1 of the second term minus y1 of the first term over second minus first. That's the easiest way to do rate of change, and it's going to keep your answer to be the most accurate. I can't on here. All right, example 3 says the table gives the average rates of change of a function f over different intervals. On which of the intervals does the function increase the most? So if you look at your chart, it gives you the interval and then it gives you the average rate of change. From 0 to 1, it's negative 12. From 1 to 3, it's 8. From 3 to 6, it's 7. From 6 to 10, it's 5. The question is, on which of these intervals does it increase the most? First of all, what does increase mean? Has to go up. So as I look at my answers, if these were all just straight up, these are rate of change and I don't have to edit anything on them. If it's a negative, is that an increase? No. So I would narrow it down to the positive values. That's the first thing, okay? Second thing is, look at your intervals on the top. Are they all the same? Not necessarily the values, but the amount of interval. No, right? The first one is going from 0 to 1. That's only 1 unit. The second one's going from 1 to 3. That's 2 units. The third one's going from 3 to 6. That's 3 units. And then 6 to 10. That's 4 units. That means my rate of change is not equal intervals here. I can't just look at these numbers and pick the biggest one. So the way we're going to do it is we would set it up almost like it's kind of an equation, but if you understand the process, it's not so bad. If my average rate of change equals my change in x, change in y over change in x, then for each one of these, I can figure out what my change was my change in y was based on the rate of change and the change in x. So I have 2 of these 3 things. Let's just say I look at this one because I'm going to rule out the negative. That's not an increase. I'm going to go to the next one. So if my rate of change is 8, I don't know what the change in y was, but it was divided by how many units? From 1 to 3 would be 2. Now, can I find my change in y? Yes, it would be 16. Now go to the next one. This time, 7 is equal to the change in y over how many units? 3. So my change in y is what? 21. And the last one, my rate of change is 5. I don't know the change in y. How many units did it change? 4. So that means my change in y is 20. So when I compare these, this would have been just negative 12 because it was only 1. But even if I included that negative there, on which of these intervals does the function increase the most? Okay, let's talk about the wording on this question too, because if it didn't say increase, let's say in which had the biggest change, now I would look at both the negative and the positive, okay? If it said which one had the biggest decrease, now I'd only look at the negative, okay? So really watch the wording on those things, okay? That's how they'll try to get you. Questions? Okay, I think I'm gonna go one more and then we'll stop. Let's go here. So function f is given by f of x equals negative 3x squared plus 7x minus 1. Which of the following describes f? First of all, this immediately should say I need to graph this because look at your answer choices. There are decimals involved there. That is not something that has, like if it was something that's factorable, I don't have to graph it using a graphing utility. I could try to figure it out using my zeros, but this is not that case. So hopefully that's your indication. You're going to grab your graphing calculator and you're going to graph this function. All right, so now let's look at our answer choices. A says the function always has a positive rate of change. What does a positive rate of change look like? It would be constantly increasing. Is that happening here? No. I cross that sucker out, okay? Then go to B. For any interval of x, the function always has a negative rate of change. That would say always down. Is that happening here? Cross that sucker out. Then I go to C. It says for any interval where x is less than 1.2, the function has a positive rate of change, and for any interval greater than 1.2, the function has a negative rate of change. D is just that in reverse. So what's happening at 1.2? It's your maximum point. If you actually go to your graph and you plot that maximum point, you would see it's 1.2, okay? I would look through my answer choices and see what kind of answer questions they're asking. As soon as you see that 1.2, hopefully that's your indication. Like, that's probably my max. Check to make sure it's your max. So what's happening before it gets to 1.2 on my graph? It's increasing. And after 1.2, it's decreasing. So C is the right answer. The function has a positive rate of change leading up to 1.2. It has a negative rate of change after 1.2. Questions, okay? This is an AP style question. So instead of just asking where the max is or instead of just asking something about it, it's going to put it into words. You got to just make sure you read it really carefully. Yep.
For the AP exam, we'll always have a calculator?
No. You have one. So on something this, you would have it. Yeah, there's 28 questions without your calculator, multiple choice. There's 12 with your calculator. And then your FRQ, 2 and 2, 2 with, 2 without. So you don't have your calculator more than you have your calculator. Yeah. Sure.